So now we're going to go over a little bit more detail of some different terms and everything. So polynomials, as I said, means more than one, just it means many. So then we have what's called a monomial. You'll notice the prefix here. Mono means one. So that just means that there's only one term in it. So here's our technical definition. It's a number or variable with whole number exponents. Adjust that so you can see it all. Sorry. Okay. And then we have, as I mentioned, there's different degrees. So to find the degree of a monomial, it is the sum of the exponents of the variables. A constant, which is just like a normal number like 3, has a degree of 0. Alright, let's do some examples then. So we're going to find the degree of the monomial. So monomial means it's one term, so we're not going to be separated with like addition and subtraction. So I have negative 2, b to the fourth, a to the second. So that's just one term, although we do have 3 different variables, well 2 different variables and then the 2 there. So what you do is you add up the exponents. So this is 4 and 2, and this is a constant. It has a degree of 0, so we don't add anything to that. We just take the 4 plus the 2, so it has a degree of 6. Okay, so here's the little tricky one. If constants don't have a degree, and that's a degree of 0, 0 plus 0, this has a degree of 0. Because really x to the 0 power is 1. 1 times 4 is 4. That's really just the number 4 right there. So that would have a degree of 0. Okay, so here, this number doesn't have a degree, and y does though, because it's not a constant, it's a variable. And this really has an exponent of 1 that we don't write. So this has a degree of 1. Okay, let's do one more. So 1.5 k squared m. Numbers don't have degrees. This has a degree of 2. This has a degree of 1. There's one m there. So 2 plus 1. That has a degree of 3. Okay, now let's look at polynomials. So I just wrote a simple definition for polynomial. Just means that there's more than one term, which really means there's more than one monomial. So they're going to be separated by addition or subtraction. Not by multiplication, because remember this is multiplication. If it's multiplication, that's one monomial. That's one term together. So polynomial, we have many terms, so they'll always be separated by addition and subtraction. Okay, so copy that definition down, and then we'll talk about how to find the degree of a polynomial. So this one's actually a lot easier. It's just the degree of the term with the largest degree. So when you have multiple terms, you just find the one with the largest degree. So we look at all the monomials in our polynomial, see which one has the largest degree, and that's the degree of our polynomial. So let's look at some examples here. We're going to find the degree of these polynomials. 4x minus 18x to the 5th. And so I look and see that has a degree of 1, that has a degree of 5. So the degree of this polynomial is 5, because this is the larger one. Okay, let's do a little bit more complicated one. All right, here this has a degree of 0, 'cause it's just a number. This has 2 letters. They don't have exponents, so they each are worth 1, so you add them together. That's a degree of 2. X squared and y, that's a degree of 3. So here's the largest degree. The degree of that polynomial is 3. Okay, we got a couple more examples. This one has a degree of 4, degree of 2, degree of 1, degree of 0. So our degree is 4 for that polynomial. And then one more. All right, this has a degree of 0, degree of 4, 2 plus 3 is 5, and 3 plus 2 is 5. So again, choose the largest. We have 2 that are 5. It's okay if it repeats. The largest degree is still 5, so the degree of our polynomial is 5. Okay, and the final thing is writing it in standard form. So typically, standard form, we put polynomials in order from the largest degree to the smallest. So we're going to write these in standard form, and we're going to give the leading coefficient. So coefficient is the number in front of the variable. So we're going to do standard form and give the leading coefficient. Go ahead and pause the video to write the definitions out. We're going to do 3 of these examples. Okay, so I'm going to go ahead and say what each degree is. That's a 1, 3, 0, 2. So I put them in order from the highest. And one super important thing is when you see this minus sign, remember that goes with the 4. So it's going to be a negative 4 x to the third. And then I take this term with the sign in front, always goes with it. And then term 1, 20. If there's not a sign, we put a plus sign, plus 20x. And then this plus 2 at the end. So now it is in order from the highest to the lowest degree. And the leading coefficient is, this number in front is negative 4. All right, so degree of 3, degree of 5. Remember the numbers don't have degrees, just one y, so degree of 1. So, the highest degree is y to the 5th. And then y to the third, and this is the smallest, so plus 4y. Now this one, what's the leading coefficient? There's not a number in front. Remember, there's always really a 1 there, we just don't ever write it. So our leading coefficient on this one is the number 1. And our last example, that has a degree of 0, 2, 5, 3. So 5 is first, x to the 5th. And then comes the 3, so plus 9x to the third. And then the 2. Remember that negative goes with it, minus 4x squared. And then last is, sorry about that. And the last here is the 16, so you put a plus 16 if there's not a sign. It's a positive 16, so we add the 16 there. So your leading coefficient, nothing in front of it, so it's really just the number 1. Those are your leading coefficients. Those are in standard form. And there are your notes on how polynomials and monomials work.